At the center of Furman's SMP Plus circuit is Series Multi-Stage Protection, or SMP. As I've mentioned before, audio-video professionals can never accept downtime, corrupted data, or unreliability. It is for this reason that a non-sacrificial transient voltage surge suppression system such as SMP is the best choice for critical applications. With SMP, there is virtually no downtime. In fact, these circuits can typically handle multiple 6,000 volts or 3,000 amp pulses without sustaining any damage. This is far beyond the demands placed on generic surge suppressors. But by constructing a circuit that is capable of this severe test, it ensures that equipment damage or maintenance is extremely unlikely. Typical surge suppressors are like an outstretched spring with a bullet headed straight for it. When a significant surge hits the device, it is often too much for the device to handle. The key to our SMP suppression system is that the severity of the offending voltage spike is critically damped so that the overall energy level is reduced to a fraction of what the clamping device can handle. So like a well-tuned shock absorber, the SMP circuit protects itself as well as your connected equipment. The problem with typical surge suppressor circuitry is a reliance on unprotected sacrificial components. When a surge enters the device, these components give themselves up in order to save your equipment. With a significant surge, in the best case scenario, this means that your device will need to be repaired or replaced. In a worst case scenario, the surge will take out the device and pass through into your connected equipment. When a surge enters the SMP circuit, the energy is absorbed within 1 nanosecond and dissipated in the form of heat. This siphons off much of the offending transient voltage spike so that the power clamping devices don't have the burden of absorbing all the energy or impact on their own. An important specification that should be considered when comparing TVSS devices is the rated clamping voltage. The clamping voltage is the maximum amount of voltage that can pass through a transient voltage surge suppression system after the circuit has clamped and dissipated the incoming voltage spike. This is an important point because a clamping voltage that is too high will fail less frequently, but at the expense of component and system failures. Since a large percentage of the clamping voltage ratings will return through your AC component's AC cord and head straight for the power supply due to path of least resistance, it's mandatory that the voltage be in range that the supply can handle. For a 120 volt AC main supply, the clamping voltage should be limited to approximately 200 volts peak. Many typical SMP, as well as conventional consumer-grade transient voltage surge suppression circuits, may feature unacceptably high peak voltage ratings for their surge suppression. Furman's SMP circuit features a clamping voltage of 188 volts peak, approximately 133 volts RMS, which any component's power supply will handle without any stress or failure. Another pitfall common in surge suppressors is ground contamination. Traditional surge suppressors and AC filter conditioners have leakage paths to ground when they shunt or divert a surge. This was considered acceptable for years due to the ability of yesterday's active devices such as vacuum tubes or valves and transistors to withstand a large, short-duration voltage arc-over without any problem at all. This is no longer the case with high-speed surface-mount integrated circuit chips. In addition to the performance-corrupting noise created by the AC voltage leakage to ground, damage to sensitive IC chips will occur over time. This is because transient voltage spikes that are clamped by a suppressor device will deliver pass-through voltage through the return or common circuit path. Since today's ultra-sensitive chips' ground pins are often connected to the AC cord's ground wires, multiple transient voltage spikes can pit or fissure the delicate junction of these devices. This isn't something that will typically occur within a matter of weeks or months, but within a number of years, electronic devices with these chips may start having inexplicable, intermittent, unreliable behavior. Remember, anywhere from dozens to hundreds of hits a day are coming through your AC tap. And even if a fraction of that transient voltage can make it to the ground pin of that chip, the cumulative effect over time is damage to your equipment. In other words, most surge suppressors may actually aid in the demise of your sensitive equipment unless the surge and filtering circuit is entirely free of ground contamination. With Furman's SMP, the surge is not shunted, it is captured and dissipated. This means no voltage is diverted to the ground and your sensitive electronics are safe from ground contamination.